This lesson is for Mrs. Cucci's College Now Contemporary Math class. Today we're going to be talking about Venn diagrams and set operations. Okay, so the first thing we have to talk about is what's called a universal set. A universal set is symbolized by an uppercase U, okay? And it's the set that contains all of the elements being considered in a given discussion or problem, okay? So it's the set of all elements being considered or being discussed. All right, so we're going to have to be able to determine sets from a Venn diagram. Now, Venn diagrams, you guys have seen before. You did them in algebra, so this isn't new. So it's just a little bit of review. Okay, so we're going to use the Venn diagram below to determine each of the following sets. So the first one is that U, right? U stands for your universal set. So I need to know what are all of the elements that we've been talking about within this set. Okay, so we're going to actually list out those elements. So the universal set is in math is an equals. And we're going to use and list them all, roster method, right? So we've got a square, and we've got a triangle, and a dollar sign, and an M, and a 5. This A represents this kind of grouped value here. It's not actually an element in the set. Okay. So now A consists of all the elements within that circle. All right. So that should be pretty simple too. We've only got a square and a triangle in there. And last but not least, it's the set of elements in U that are not in A. So the set of elements in U that are not in A. Okay. So they're the elements that are outside of this circle. So the set of elements that are in U but not in A are going to be that dollar sign, the M, and the 5. So it's basically just looking at this Venn diagram and determining where things are. All right? Okay. All right, so representing two sets in a Venn diagram. So relationship 1 is what we call disjoint sets, two sets that have no elements in common. So a representation of that is, let's say I've got this set, the universal set, right? And I've got set A and I've got B, and they don't share anything. They've got nothing in common with one another. They're totally disjoint. They don't overlap. There's no elements that are in A that are in B, and vice versa. The next one is what we call proper subsets. So what that means is all of the elements in one set are also in the elements of the second set. So what that might look like is, let's say I've got set B, set A, everything in set A is in B. Okay? Everything in A is in B as well. Not everything in B might be in A though. So you gotta make sure you're really looking at that picture to make sure it makes sense. Relationship 3 is our equal sets. If A is equal to B, then set A contains exactly the same elements as set B. So what that might look like. You've got your universal set, and we can say A is equal to B. Okay, so they share everything exactly the same. The fourth and final relationship are going to be sets with some common elements. Set A and set B have at least one element in common. And that's where we get our typical view of that Venn diagram that we're used to seeing, right? They kind of had that shared region, and the elements that they share sit right in here. Okay, so let's go about how we use this. So my picture is not exactly where I like it, but we're going to determine sets from the Venn diagram. We're going to use the diagram below to determine each of the following. So the first one is the universal set. Okay, so I want to know everything, all of my elements, right? The universal is everything that there is. So I actually have to go through and I have to list everything in this picture. Every single element I see gets listed. Okay? So, I apologize, but I'm going to lose part of my picture here. We're going to have the universal set. It's going to be A and B and C and D and E and F and G. So it's every single element that you see in that picture. All right, so the next one, I just want the elements in B. Okay, so the set of elements in A, the set of elements in B. So here's B, right? Here's the circle B. So I have to include everything within that circle. Even if it's shared, I have to include it. Okay, so I've got D and E. The set of elements in A, but not in B. Okay, so A, but not in B. Now, D is in that shared region. So I don't want it because it's in B. Okay, so this is just going to be A, B, and C. The next one is a set of elements in the universal set that are not in B. Okay, the elements in the universal set that are not in B, so it's going to be everything minus the ones that are in B. So I have to have A, B, and C, and F, and G. Okay, I can't include these two because they're in B. And lastly, the set of elements that are in both A and B, A, B, C, D, E. F and G get left out because they're not in A or B. All right, so I hope you were able to do that with me. Okay. So now let's talk about the definition of intersection of sets. The intersection of set A and B, the way that we write that is going to be with kind of like an upside down capital U. It kind of means and. It's A and B. Okay. And that's this element of the elements common to both A and B. And I seem to have missed something here. We need to add a little something in here. We also need to talk about the complement. All right, so write this in. And the way we represent that is, say, of set A, we would say it's like A prime, okay, it's the complement, is all of the elements in the universal set that are not in A. So all elements I don't know why I didn't have that in there. Okay, so it's all the elements that aren't in A. Another way to write it is the complement of A, X such that X is an element of the universal set, and X is not an element of A. So it's just another way to write it. All right, so let's talk about intersection of 2 points. So if I'm looking for the intersection of 2 points, it's actually really simple. What you're doing is you're finding what they have in common, okay, how they match up, their intersection, all right? So if I look, I've got 7, 8, 9, 10, 11, and I've got 6, 8, 10, 12. Okay, so what you're looking for is what they have in common. So if you look at the first set, you've got 7, 8, 9, 10, 11. In the second set, you've got 6, 8, 10, and 12. So what we're going to do is we're just going to match up what we have that's alike. So I've got an 8 here and an 8 here. And I've got a 10 and a 10. So that's what their intersection is going to be. It's going to be those two values, okay? So we're going to do that again for the next one. So we're going to look for common elements. 1, 3, 5, 7, 9, 2, 4, 6, 8. So this one, I actually don't have any common elements. So the intersection is actually that empty set. And then the last one, I've got 1, 3, 5, 7, 9, and intersecting with the empty set. And again, there's nothing in this second set, so your intersection again is the empty set. All right, so let's talk about the definition of the union of sets. So the notation kind of looks like a U. And what it is, it's the set of elements that are members of A or the set of B or of both sets. So the definition can be expressed in set builder notation as well. So you have to write this down. A union B, X such that X is an element of A or X is an element of B. So what this looks like is actually taking those and using all the elements from each. You're not going to rewrite any. You're simply going to list them out. So I have a 6 and a 7 and an 8. I have 2 8s. I'm only going to write it once. 9, 10, 11, and 12. So you're taking the union of them. You're putting them together. Next one. 1, 2, 3, 4, 5, 6, 7, 8, and 9. I'm using each element from both and I'm putting them in order. And then the next one is this first set union the empty set. So you still have to take the elements in the first set. And since there are no elements in the second set, you're just going to leave it at the first set. So those are pretty simple. All right, so empty set and intersection and union. For any set A, you're going to have, oops, what's happening here? A with an intersection of the empty set is going to be the empty set. A union the empty set is going to be A. All right, so let's perform some set operations. So the first, what we're going to do is I'm going to give you a couple of sets. The union, or the universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Set A is 1, 3, 7, and 9. Set B is 3, 7, 8, and 10. I want to find the complement of A union B and A complement intersect B complement. Okay, so we're going to kind of do this out. So first thing we need to do is look at A union B. Okay, union means we're going to be uniting them, right? So we're going to list them out. We've got 1, 3, 7, 8, 9, 10. But since there's that complement, I want the complement. So what I'm going to do is I'm going to take everything from this universal set that I haven't listed here, and that's going to be my answer. Okay, this here is A union B. I now want the complement. So I want everything in here that's not in here. So I've got the 1, I don't have the 2, I've got the 3, I don't have the 4, I don't have the 5, I don't have the 6, I've got the 7, 8, 9, and 10. So there's its complement. Not bad, right? All right, so A complement intersect B complement. So I got to find the complement of A to start. So I've got 1, 3, 7, 9. The complement is going to be everything in here that's not here. So 2, 4, 5, 6, 8, and 10. B complement, same thing, everything that's not here. 1, 2, 3 is there, 4, 5, 6, 7 is there, 8 is there, 9. Now I want the intersection. So again, intersection was what they had in common. So they've both got a 2, and a 4, and a 5, and a 6. So that there is your intersection. 2, 4, 5, 6. All right. Use the Venn diagram below to determine each of the following sets. So A union B. So union means I'm uniting everything, right? So we're taking all the elements in A and all the elements in B. So we've got pi e square root of 2 square root of negative 1 e to the pi I 10 to the 100, whoops, and 2 to the, I don't know what that is, XO. Okay. Now let's go to the next one. We want the complement of that. So everything in the universal set that's not in this list, which looks like just 666. A intersect B, so what do A and B have in common? Just what's in that center region, right? It's what they have in common right here. A intersect B complement, so everything that's outside of that region. Pi e to the pi I, 10 to the 100, 2 to the x sub o, and 666. It's part of the universal set, even though it's not part of AB. A complement, intersect B. So that's going to be the set of all the elements that are not in A and are in B. So elements that are not in A and are in B. So we've got e to the pi I, because it's not in A, but it is in B, 10 to the 100, and 2 to the x sub o. Not in A, but it is in B. A union B complement. So that's going to be the elements that are in A or not in B, or both. Okay, so they've got to be in A or not in B, or both. Okay, so the complement. So we've got pi and E definitely in A. We've got square root of 2 and square root of negative 1 is still in A. And 666 because it's that complement to B. And there we have it. All right, so when using the work, when using the word, that should say word or, this refers to the union of the sets, okay? When using the word and, it refers to the intersection. So formula for cardinal number and union of two finite sets. We've got n of A union B equals the cardinal of A, cardinality of A, plus the cardinality of B, minus the cardinality of A intersect B. So that's the formula we use. Okay. All right. So we're going to use this formula, the cardinality of A union B. All right. So again, remember, cardinality means the number of elements within the set. Okay. Some of the results in campus blood survey indicated that 490 students were willing to donate blood. 340 were willing to help serve a free breakfast to the blood donors, and 120 were willing to do both. How many students were willing to donate blood or serve breakfast? Okay, so I've got 490 in my first set that are willing to donate blood. 340 in my second set that are willing to give out a free breakfast. And then 120 who are willing to do both. So we're going to add these together. I get 830 minus that 120. And the cardinality of the union of sets is 720. Okay, so you're going to be doing the practice 2.3 document for this. And make sure to show me your notes, and I will see you tomorrow. Thanks, guys.